Your brain makes up about 2% of your body weight, but it burns roughly 20% of your daily energy, just sitting there, thinking. No other organ comes close to that ratio. For most of human history, that kind of energy demand should have been a serious liability. So how did a species with limited access to food afford to run something this expensive? The answer might come down to something you did yesterday without thinking twice about it. Cooking. To understand why that matters, look at our closest living relatives. Chimpanzees spend nearly half of their waking hours just chewing. Raw plants, tough fibers, dense proteins, none of it breaks down easily. Their bodies have to work hard just to extract usable energy from what they eat, and a huge portion of their daily energy budget goes straight back into digestion itself. There's very little left over for anything else, biologically speaking. But cooking changes the equation entirely. Heat breaks down plant cell walls, unwinds proteins, and softens tough tissue before a single bite reaches your stomach. In effect, cooking is a kind of digestion that happens outside the body, using fire instead of stomach acid. The result is that a cooked meal delivers significantly more usable energy per bite than the same food eaten raw, and it takes the body far less work to extract it.
That freed up energy had to go somewhere. According to what's known as the cooking hypothesis, proposed by primatologist Richard Wrangham, that surplus energy is what allowed early human ancestors to support a larger, more expensive brain without needing to eat constantly just to keep their bodies running. Less energy spent digesting meant more energy available for an organ that, evolutionarily speaking, is remarkably costly to maintain. There's a timing argument that makes this even more compelling. In the fossil record, brain size in the human lineage begins expanding dramatically around the same general period that evidence for controlled fire use starts appearing. That doesn't prove cooking caused the change on its own, but the overlap is hard to ignore, and it lines up with what we know about the energy economics involved.
Not every researcher agrees on the details. Pinpointing exactly when regular cooking began is difficult, since fire leaves fragile evidence that doesn't always survive hundreds of thousands of years. Some scientists argue the timeline proposed by the cooking hypothesis is too early for the archaeological evidence currently available. The correlation between brain growth and cooking is compelling, but correlation alone doesn't settle a scientific debate this old. Still, the core insight holds up under scrutiny. Something had to pay the energy bill for a brain this expensive, and raw food alone struggles to cover the cost. Cooking, whatever its exact timeline, freed up resources that a growing brain could put to use. So the next time you put something on the stove, it's worth remembering that you're not just making dinner taste better. You may be repeating the exact behavioral shift that once helped free up enough energy for a brain to grow into the very thing capable of asking why it exists in the first place.